Hello fellas, welcome back. Hopefully now we're done with elimination, substitution. We did a lot of word problems. So hopefully we developed some more problem solving skills. We learned how to use substitution, elimination in that process. The next couple of videos we're going to focus on partial fraction decomposition. The best way to learn about partial fraction decomposition is to do some examples. I'll outline the steps that you have to take, and we'll do some different examples. In this video, I'll give you the real basics and an introduction to it. I'll give you some practice problems, and then the next video we'll do some more complicated ones where we have to do a few more steps. Okay, well, let's get started. So if I want to look at writing a partial fraction decomposition of this expression, we need to follow some basic steps and some basic guidelines. Okay, so step one is always the same. Step one is if the power in the numerator is greater than or equal to the power in the denominator we want to divide. So if there was a 7x squared or 7x cubed term up here, then my first step will be to divide. In this example, don't need to do that because the power up here, we don't even have an x term, so the power in the numerator is greater. So we're going to proceed right to step two. Okay. Step two says completely factor the bottom. All right, and to factor the bottom, I basically need to just take out an x. All right, that's all I need to do in the step two, factor the bottom. Okay, so let's do that. So these two statements are equivalent. Now, when we talk about the decomposition, we're talking about breaking this term up into the sum of at least two terms or possibly more, depending upon the number of factors that I have. So basically, this third step is decompose the rational expression. So what I want to do is rewrite this side right here like this. All right, I want to write this as a over x plus b over x minus 14. You will actually use this in calculus, all right, when we start talking about some things called integration, and this is going to be important. So you need to know how to do this. So again, if I'm looking at that, all I want to do is I want to put a over the one factor and b over the other factor. And these are both linear factors right now. We'll learn how to handle quadratic factors later. All right, so there's the third step, decompose the rational expression. Step 4, multiply by the least common denominator. In this situation, if I have this equation, my least common denominator is what's going to be left on the left-hand side, x times x minus 14. Okay? If I do that, if I multiply that through, the left-hand side is left with 7. Then I have a over x times x minus 14. The x terms here are going to cancel, and I'm going to be left with a times x minus 14. And I'm going to let b times x because the x minus 14 terms here will cancel. Okay? Now the goal is to solve for a and b. And I can plug in x values to solve for a and b. If I plug in 0, what it's going to allow me to do is to solve for a. And if I plug in 14, I'm going to solve for b. Notice that when I plug in x equals 0, this term goes away right there. I'm left with just an a. And if I plug that in, I should see that a, 7 is equal to negative 14a. So a should be equal to negative a half. And then when I plug in 14, that term is going to go away. And I should see that b is equal to a half. Like that. Okay? Again, make sure you pause it and work it through here. Now what I want to do is just rewrite the final answer. And the final answer is going to look like this. This right here can be broken down to this statement right here. Well, remember, I said that this, I had x, I had x, 7 over x times x minus 14 was equal to a over x plus b over x minus 14. We said that a was equal to negative 1/2 and b was equal to positive 1/2. And so I simply plug that in, okay? And that's why I did switch the terms because of the minus sign. All right? Let's do another example. In this situation, again, step 1 says the power. I have to look at the power in the numerator and the power in the denominator. The power in the numerator and denominator are the same. So that means I have to do long division. So let me do the long division out for you. You guys should stop and do this as well. So I have x squared divided by x squared minus 1, you get 1, x squared minus 1 plus 1, so I have a remainder of 1. So I can rewrite this and say that this is equal to 1 plus 1 over x squared minus 1, like that. Okay, you guys should see that. Eraser. Now, if you didn't get that, you got to go back and you have to review on how to do long division, which was way back in the beginning of the year. Okay? Now, once I do that, here I am. I want to break this term here. I want to do partial decomposition on that one. And so what I need to do is I need to factor that denominator. You guys should note that that's the difference of 2 squares. Like that. Okay? Now I have two linear factors here. And at this point, what I want to do is I want to write the decomposition of this term. We'll come back and we'll put that 1 back in later. So I want to write the decomposition like that. Let's leave this side alone. A over x plus 1 plus b over x minus 1. Okay? Now at this point, I want to multiply by least common denominator, which is x plus 1, x minus 1. Like that. On the left-hand side, I'm going to be simply left with 1. On the right-hand side, I'm going to be left with a times x minus 1 and b times x plus 1. Like that. Okay? At this point, I want to choose x values carefully so that I can solve for a and for b. If I want to solve for a, I'm going to plug in x is equal to negative 1, because by plugging in x equals negative 1, this term goes away. When I want to solve for b, I'm going to plug in x is equal to 1, because this term goes away. Okay? If I plug in 1, I get rid of the a term. I get 2b is equal to 1, so b should be equal to a half. If I plug in negative 1, I get negative 2a is equal to 1, or a is equal to negative a half, like that. And the final step is to rewrite is the total decomposition. 1 was from when I did the long division. 1 over 2 times x minus 1 minus 1 over 2 times x plus 1. Okay? And you guys should be able to show that these two things are the same. All right? And actually, let me do that for you quickly. If I look at the 1, I'm going to have 1 is going to be x squared minus 1 over x squared minus 1. That's the 1 term. Plus the common, let's get everything here with a common denominator. Let's get these two terms with a common denominator right here. The common denominator for these two terms is 2x minus 1 and 2x minus 1 times x plus 1. So I'm going to multiply. I'm going to have x plus 1 over 2 x plus 1 x minus 1, okay, minus x minus 1 over 2 x plus 1 x minus 1. That's, this term is right there. Whoops. And this term is right over there. These two have the same common denominator. And so what I will get is, if I combine those two right there, I'm going to get the x plus 1 minus x plus 1, okay, because I got to distribute that negative, over 2 x plus 1 x minus 1. That term now becomes 2 over 2 x plus 1 x minus 1, like that. The 2's cancel. Okay? So now what I need to do is combine it with this first term. X squared over x squared minus 1 over x squared minus 1, like that. And this is plus 1 over, I can distribute, that's x squared minus 1. And if I combine those terms, I get x squared over x squared minus 1, which is the same as what I have over there. Okay? You guys should do that out for yourself. You guys should go through the steps. You guys should be able to reduce those fractions and show that just like I did. Okay? Those are two pretty straightforward examples. I want you guys to read section 7.4. I want you to focus on examples 1 through 4. Okay, they show you how you handle different situations. Here's some straightforward and basic practice right here. Okay, in the next video we're gonna look at some more difficult problems where we're gonna have quadratic factors in the denominator. We're gonna do some more with the long division. We're gonna look at repeated linear factors. So there's a bunch of different rules, so you have to practice them. All right. Examples 1 through 4 will show you a lot of the real basic stuff. The next video will ramp it up a little bit. Okay. Email me with any questions. Attend some Google Hangouts, and we'll get this introductory stuff squared away. Okay, fellas? Have a good day.